Yes.
Yes.
Hi everybody, my name is Niklas Forsgren. I work as an FAE director at Epishine. Epishine is a Swedish company that produces indoor solar cell in a roll-to-roll fashion. First of all, I would like to thank the organizers for having us here today and for us to have the possibility to stand here on stage and present the thing we are burning for. I'm here with Pierre today to talk about indoor asset tracking powered by light. Over to you, Pierre.
Yes, thank you, Niklas. Thank you very much to the organizers for having us. I'm Pierre GELPI from EPs. I'm in charge of sales for Europe. I'm very happy to be here again at the Things conference and to talk about asset tracking again.
Yep.
I think to start, Niklas has a question for you.
Yes, I do actually. The T in IoT, do you actually know what it stands for? I mean, we are at the conference, one of the biggest IoT conference in the world. So I guess you think you know what it means? I think I know what it means. Pierre, do you know what it means?
Yes, I also think, like all of you, that I know what the T means. But actually, I discovered that all these things have batteries, right? So if we want to scale, what can we do with all these batteries? We are throwing away 900 batteries per second. They need to be replaced. And it's not only about the cost of the battery. You can tell me a coin cell costs nothing. Yes, but the cost of replacing it is a lot more. And it's killing really the scaling of IoT. So we cannot go on for that for two reasons. One, of course, is the maintenance costs that I've been talking about, but also for the planet, right? All of this is toxic waste, and this is just not sustainable. So, Niklas, how can we do that?
How can we do that?
Yeah.
Yes, as we talked about, many of the IoT devices today are powered by batteries, and worse, they are powered by disposable batteries. And IoT at scale can never happen with disposable batteries. So we kind of need to find somewhere else to store the energy, because we always need to store the energy for the night or something like that. So we need to look into rechargeable solutions. And if you can also add an energy harvesting source to your product, then you will have a never-ending source of power for your product. And with the manpower, the cost, and the waste that disposable batteries put on us, IoT at scale can never be sustainable with disposable batteries. So we need to move away from that. The problem we have today is that engineers, they really know how to design with a battery, put it in there and choose it. So we need to educate them and help them change the mindset of how to design IoT products. And by adding energy harvesting to that, make it sustainable for the future.
Yes, so let me tell you about one use case that we have, real-life use case from Thales. For those of you who don't know Thales, Thales is one of the largest European provider in the aerospace area. And here are two use cases. So the first one I've seen in the past already, in my previous life. It's about manufacturing orders, work orders, monitoring. But what I've seen in the past is that it had batteries, and these batteries needed to be replaced after a few years, right? Often people tell you 5 to 10 years, but in reality it's 2 or 3 years. And again, that kills the business case. So now it's really install and forget. It's unlimited battery life. You just install and forget. Work orders are materialized by these gray boxes that you see on the top left picture. And each area of the factory represents a special task. So by geolocating these boxes in the factory, you actually follow the manufacturing process. And they are using simple BLE tags like the one I have here, except that these ones, they have a little LEDs. And when the workers have to start a new task, they can select very easily, very quickly, the high priority task thanks to the LED. So that saves a lot of time in selecting the high priority task. But the additional benefit for the central process is that the lead time prediction accuracy gets better, right? Because before that, they were taking any task, and then the tasks were not done in the right order. So there is a huge improvement in lead time prediction accuracy, which is good for the customer relationship. And also what they call scheduling adherence, so meaning the difference between what was planned and what is actually executed. This is what they call scheduling adherence, and this massively improves like something from 30 to 90%. This is really incredible thanks to this use case. The second use case is more always using the same device, a simple BLE tag, and it's more about automated inventory of this measurement equipment, because they are sharing this equipment between different teams. So when they need it, they don't know where it is, and having this BLE tag to geolocate it, again, saves a lot of time to find it, and it reduces the downtime, because of course, if the maintenance has not been done, they have to stop production, and this is a huge cost. So this is really reducing also production downtime. And Niklas has more ROI figures for you.
Yes, another common customer of us, Minu, released this tracker, also a BLE tracker, this spring called MTB11. And in this case, we're going to look into more the kind of investment costs for choosing a energy harvesting tag versus a battery powered tag. We have been given these figures by Minu, and I will kind of walk you through it to explain what it is. So let's assume you're going to order or deploy a tracker system. And in the initial part, you have to look at the initial hardware you need to buy. And if you look at the numbers here, you see that the battery power is almost half the price of the energy harvesting device. So of course, that's the winner in the first place. You just pick that, and you deploy it. And then after a few years, you see that the batteries start to run out, and you realize you have to do something about this. So you call in your maintenance crew, and they collect the tags, they replace the batteries, and they have to redistribute the tags. All of this, of course, is at a cost. And as Pierre already said, the battery cost is not the big issue here. In this case, Minu are estimating this cost to $25 in just labor cost. So all of a sudden, the initial cost of half the price has now turned into double the price of the energy harvesting device. And continuing over the years, this is just for, say, 2 years or 3 years. For the product's lifetime, you probably need to do 2, maybe 3 battery changes, increasing this cost enormously. So we need to get the procurement team to kind of look up, see the whole picture, consider the total cost of ownership for the whole lifetime of the product. Because as we see here, I mean, we have an initial cost that is higher, but one battery change changes that completely. So we really need to move into energy harvesting devices. And I mean, where there's people, there is light, so why not use it? Convert it, harvest it, do something useful with it. And I promise you, we can power many, many of the IoT devices out there with energy harvesting. So Pierre, how does it happen?
Yeah, so as you said, it's slightly more complex than simply putting a battery, but it's not so complex. And we are, of course, here to help you in this journey. So these are the blocks that you need for energy harvesting. Obviously, a source on the left side, storage on the right side, and in the middle, power management, electronics, and PMIC is the most cost-effective way to do it. So starting from the left, photovoltaic cell, in this case, indoor photovoltaic cell, the 3 criteria that you really have to look at when you select the PV cell is, first of all, the performance. So, of course, measuring the performance of the PV cell out of production, not out of the lab. Second, aging, because we have seen some surprises with some providers. So if the PV cell dies quicker than the battery, it doesn't make sense. So you need to have a PV cell, and there are some PV cells out there, including these ones, that live for 10 years and more. So aging is an important criteria. And the third one is manufacturing process, because not all players are able to produce in volume. And of course, we all want to scale, so this is very important to be able to produce in volume. Then storage elements on the right side. It can be, of course, a battery. It doesn't need to have lithium. There are some NEMH batteries, for instance. It can be a super cap, of course, and there are also some hybrid caps that are a little bit taking the best of both worlds, I would say. And in the middle, you need some electronics because all the voltage ranges of the source and the storage are not the same. So you also need to protect the storage element against overcharge and over discharge. So this is what our chip is doing in the middle. It's again the most cost-effective way to do it because it's integrated, optimized. It takes less space on the board, less time for the designers, and you have everything optimized. It's very efficient in harvesting the energy, protects the storage element, fuels the application, and we also have additional features like 5-volt input for USB recharge or APM to know the energy available in real time on the source and the storage, etc., etc. So this is how it works, basically. And the way we work with you is really by just starting from the size and consumption of the device, and Niklas will explain more.
Yes, so what do we need? Yes, in order to power your device by only light, we of course need to know how much it consumes. And we've done an example here to just give you some numbers on what is actually needed. And the assumption we have made here is that your device will consume 20 microwatts on average. We assume a 10 square centimeter PV cell, and we assume a very efficient PMIC in the middle with some efficiency number there. Move over here to point a bit. So in this table, let me move into that. On the left side, you have the light conditions from very dark to next to the windows. And again, the associated lux levels to that environment. What you see here is the expected power output per square centimeters at that lux level. And then moving into the result table, on top, you see the number of hours that light is available. And in the table, everywhere you see a number, we have a life extension. As soon as this says auto, we are in autonomous mode. And in this case, we are harvesting more energy than we are consuming, which means this device will run forever. And in this case, in these assumptions, you see that already 8 hours at 200 lux will give you autonomous power to your device. I mean, 200 lux is maybe not that easy to grasp what it is. So I encourage you all to download the LuxMeter app to your phone. And during these 2 days, go around, take some measurements, and see where we are at different places, and try to get a feeling of what 200 lux is. It's not that much, I can say that. But yeah, energy harvesting is the future for IoT devices, I would say. It's what makes it scalable. What makes it possible to deploy at really big scale.
Yeah, 200 lux is what we have on the booth.
Yes.
So you can visit our booth later on. It's B5, but before that, stay in the room because we have a panel. So please stay in the room. You will be able to learn more with our friends also that are joining us for the panel. Thank you very much for your attention. And yeah, stay for the panel and then visit our booth.